Hey everyone, today we're going to be learning how to make Space Invaders inside of the Go programming language. I'm going to be using Raylib as my graphics engine, and this is really just a tutorial for beginners. Now, I have already made another video where I made Flappy Bird, so be sure to check that out. So here's a small demo as to what we're going to be making. Alright, it's just Space Invaders, right? So there's enemies here, and they fire, and you can also fire back using the space key. Alright, and as you can see, their shooting thingy, it hit mine, so I lost. So yeah, my final score is just 50. Now you guys might be wondering that this isn't exactly accurate when compared to the real Space Invaders, but I mean, I'm trying to make tutorials out of a literal graphics library that has little to no internet support, so there's not really much you can really expect from me. All the assets, such as the images, can be found on my GitHub with all the code below. Now let's just go ahead and start the video. First thing we are actually going to want to do is go ahead and install Raylib. If you haven't installed it, or if you have installed it, then just go ahead and skip to the next part. But in order to install it, open up to your terminal. Alright, I'm just going to full screen this. Alright, and I want to type go get this link, and it'll just install it for you. So that's basically all you have to do. But make sure that you actually have Go installed on your system, otherwise this won't work at all. Anyway, let's go ahead and move on to actually writing some real code. Alright, the first thing we're going to want to add is our black screen. Alright, and this black screen is just going to be the background in which the player is going to play. So, to do this, first of all, let's just open up a file, alright, and just call it main.go. Make sure you installed your assets, by the way, because that's the thing that we're going to do next. We're going to add in our player. Okay. So the only thing you really need to import right now is just the Raylib library. So remember how a couple of seconds ago I installed that Raylib package using go get? Yeah, we need that exact same thing, and make sure you wrap it in quotation marks. Now that that's done, go ahead and create a main function. This is where all your code is going to be executed. So the first thing we're going to want to do is go ahead and create two main variables, screen width and screen height. So screen width. Alright, and just use a declarative operator and set that equal to 600. And make sure that it's an int32 because that's the format that Raylib supports. The next thing we do is go ahead and create our screen height. Our screen height is going to go ahead and be 900. Alright, so now we're going to get sort of like a nice vertical standing rectangle shape. Now the next thing we want to do is go ahead and actually create a black screen around our window. So first thing we want to do is just go ahead and initialize the window. So we're going to go rl.initWindow. Alright, and we're just going to go screen width, comma, screen height. Alright, and then we're just going to go now we're just going to give it a title. I'm going to call it Space Invaders. The next thing we will want to go ahead and do is just create a true for loop. So to do this, just go for, and as long as the window has not closed, it's just going to keep on running. Alright, and the reason why we're doing this is because we constantly want our images to keep on being rendered onto the screen, so it'll make it look like it's not so that way each time there's a change, you can see the changes. Alright, now that that's done, what's the error here? Yeah, okay, now that that's done, the next thing we want to do is go ahead and start drawing. To do this, just go rl.begin drawing. The next thing we're going to want to do is just clear our background, rl.clear background. So what clear background does is it basically just clears out the background and it puts a specific color in there. So we're using rl.black. The next thing we do is we're actually going to want to end the drawing, so that way we can start drawing once again. And if we don't do this, then what's going to happen is that our system is just going to crash. Because what's happening is that we're constantly drawing over and over again without ending the first one we started. Alright? Now let's suppose if the player wants to stop playing, right? It's going to close this entire screen. But the main function is still going to run. So now what we need to do is actually close the entire window itself. So we're going to go rl.close window. Alright, now that that's done, let's go ahead and run this. Okay, so to run this, just go run main.go. Cannot use. One moment. Okay, there appears to be an error. let's just read what the terminal has to say. Cannot use screen width as type int. Oh, I forgot to write this as an int32. Okay, anyway, now let's go ahead and run this. So, okay, so as you can see, there's no errors here. And inside of my other screen, I got my black screen. So now inside of here, we're going to set up our character controller. We're going to also have our enemies and bullets and our scoring system. So now the next thing we're going to want to do is go ahead and begin with our character controller. So let's start. So to set up your character controller, the first thing you need to do is, install these assets. Now I'm under the assumption you guys have already done it. Also, for some reason, OBS is displaying the color as black, but it's really green. I don't know why. But anyway, let's move on. So the first thing we want to do is go ahead and load in our image. Now, the way we load it is pretty straightforward. But before you guys do that, make sure that when you load it, it's right below the Windows initialization. This is because if it doesn't work, if you don't do it right, then you lead to a stack error. Because what happens is that you want your window to come first and then all these extra stuff. Alright? So to do this, first create a variable, and I'm just going to call it ship image, okay? I'm going to use a declarative operator, and then I'm just going to go ahead and load the image. I'm going to go rl.loadImage, and I'm going to load the image, and I'm going to specify its path, which is just assets/ship.png. Now that that's done, I now need to convert this image into a texture so it can be controlled via my mouse or my keyboard input. To do this, just go ship, alright, and that's going to be our new variable, and that's going to be our texture, by the way. And just call it rl.load texture from image, and we're going to load in the ship image, alright? Because we first load in our image, then we convert it into a texture called ship, alright? Now the next thing we also need to do is go ahead and we need some x and y coordinates for our ship to move through. So, create two variables that are int32s, okay? One called x_chords, okay? And y_chords, okay? And 32. Alright, and I'm going to set the x coordinates as 2. I'm going to set my y coordinates as 800. Y chords and 32 as 800. Alright, now one thing to know about Raylib is that the way the canvas works is a bit different. So instead of the x coordinates being like maybe here, look at where my cursor is, the x coordinates actually start from all the way at the bottom. That's why I'm putting x2 over here. So the image is going to be right at the bottom, similar to where my cursor is. Alright, now that we have all of this set up, the next thing we need to do is go ahead and just draw this texture. So to draw the texture, do it right below the clear background. So we're going to go rl.drawTexture. Okay, and we're going to first of all draw in our texture, which is ship. Then we're going to go x chords, y chords, y chords, and we're going to give it a color, right? So the color is really just going to be overwritten by the black, but I'm just going to put it as rl.white. This is because, just because. Okay. The next thing we want to do now is go ahead and set up some character controller inputs. So, for now, we're only going to use the A and the D key to move the character left and right. So we're going to go if rl.isKeyDown, alright, and we're going to check to see if the D key is down. rl.key D. If in the case that it is down, what I now need to do is actually check for one more thing. The next thing I want to go ahead and, actually, you know what? We'll deal with that later. All I'm going to do is I'm going to take the X chords, I'm going to go ahead and add 5 pixels to it. Similarly, if rl.isKeyDown is rl.keyA, and what we now need to do is just go X chords minus equal to 5. Alright, now let's go ahead and run this game. Whoops. Okay. Alright. Now that we're running this. Okay. So here's the screen. Now watch what happens when I click A and D. It moves. But you might be noticing two things. One, it's going off the screen, and two, it's moving pretty fast. Now the reason why it's moving pretty fast is, for now, it may seem like a disadvantage, it may seem bad, but the reason why we're doing this is because once we load the enemies, we actually want to slow down the game so that we can actually see the animations a bit more clearly. So for now it might be fast, but eventually it'll, slow down. Now, the other issue is that the character is actually moving away from the screen. To do this, we're actually going to make another if statement inside of the D and the A if statements in order to prevent that from happening. So, inside of our D keyboard thing, we're going to go if, we're going to go ahead and check to see if the X chords, and we're going to add one obviously, because we want to see ahead, right? If X chords plus 1 is greater than or equal to the screen width, then we're not going to want to do it. However, if it's not true, so if it's false, then we're going to want to attach it on. Okay, and we're just going to go ahead and just copy and paste this. Right over here. But instead of using screen width, we're actually just going to want to go 0. And we're going to go minus equal to 1. Or minus 1. Okay? And put that as minus. Alright, so now look what happens. Go run main.go. Okay. Yeah, so as you can see, where'd it go? X chords. We have our if statement right there. X chords minus 1. Oh, sorry. I meant less than. Okay, now let's try. Okay, so here it is. So as you can see, the character, it's now not moving back. Alright? Now you might be noticing that the character is actually moving away from the screen, but it's actually just moving right over to the edge. The reason why you can't see is because the edge is actually away from what we can see on the window. If you guys want, you guys can modify that, but I'm not going to. The main reason is because the enemies also move to the edge of the screen, so it really just balances out. Okay, anyway, now the next thing we're going to want to go ahead and add is a shooting mechanism as well as some enemies. Let's start off with our shooting mechanism. So the first thing that's needed in order to make our bullets is, first of all, we need to create a struct that has all the basic DNA. So to do this, head on over above your main function, and we're going to create a new struct called bullet. So we're going to type, so this is how you create a struct, by the way. Type bullet struct. Okay? Now, we're going to have certain attributes for our bullet. We're going to first of all have our X position, which is an int32. Our Y position, which is also int32. We're going to have our velocity, which is also an int32. And our bullet is really just going to be a huge circle, so we need our radius, which is going to be a float 32. Okay? This is that we have like some sort of decimal precision. The next thing we also need to do is create a boolean called draw. This is so that, because certain bullets won't be drawn if they're away from the screen, so we'll just set that to false instead of wasting, machine power. The next thing we need is a color, the color for our bullet. This is because both the enemy and the player will be using this exact same struct. Okay? rl.color. Now that that's done, the next thing we need to go ahead and do is create a slice of this array, or a slice of this struct. To do this, head on over right over here is fine. Okay? And we're going to create our bullet struct. So we're going to create a slice of bullets, and it's just going to be called bullets. Alright? And we're going to use the declarative operator, and we're going to have 2 square braces, and what this declares is that it's going to be a slice, so there's going to be multiple structs. And we're going to type in the struct name, which is just bullet, and then we're going to have our curly braces to declare that it's a struct. Okay, now that that's done, the next thing we want to do is go ahead and loop through every single one of these. Or no, the next thing we actually want to do is go ahead and create a keyboard detection. So to do this, what we're going to do is go ahead and create an if statement right over, let's just do it right below A. Okay? And what we're going to do over here is check to see if rl.isKeyDown, and the key that we want down is just our space key. Dot key space. Okay, and whoops, the hell. And if it is down, what we now need to do is go ahead and create a brand new struct of bullet and call it current bullet. Okay, and use the declarative operator to create the the bullet itself. Okay, the first thing we're going to want to do inside of the bullet is set up its x and y coordinates. So the x coordinates are really just going to be an in32. Okay, and it's going to have our current x coordinates. But what we're also going to do is we're going to go ahead and add 25, or we're going to go ahead and add 50. Now, the reason why we're adding 50 is because we want the bullet to align exactly with, we want it to align exactly with the image of the, of the ship. Now, in order to align with the ship, we have to sort of change up the x coordinates by a bit, so we're adding it up to 50. This way it's going to be right at the center of the bullet. The next thing we're going to want to do is go ahead and add some y coordinates. So we're going to put an in32, and we're going to put y coords. Okay, but we're also going to want to add 25. The reason why we're adding 25 is because we don't want the bullet to touch the player. Because if it does, later on in the game, it's going to be programmed so that the player will die. Alright, now the next thing we will want to do is go ahead and give it, what's the next thing we have to give it? We have to give it some velocity. So we want it to increase by 5, similar to that of the player. So we're just going to write 5. The next thing we write is our radius. So we're going to give it a radius of just 10. And remember, it's a float 32, so we're going to have to wrap that around. The next thing we have to do is go ahead and check to see if we want to draw it. We right now want to draw it, so we're just going to write true. The next thing we do is give it a color. I'm going to give it a color of just white. You guys can customize this to whatever you guys please. Now that that's done, what we want to do now is go ahead and append this over into our slice of structs. Current bullet. Okay? Now that all of this is done, what we now need to do is go ahead and, draw all of these. In order to draw all of these, all we have to do is loop through every single bullet, or we have to loop through the entire slice and just draw them out. So doing this is actually pretty simple. First thing you're going to want to do is just write a for loop. So for index 1, comma, current bullet, declarative operator, range bullets. Okay, so all this does is, so right now all we're doing is we're taking our bullets and we're keeping into account of two things, the index and the current struct itself. Now the next thing we want to do is go ahead and create an if statement that checks to see if we should draw it. To do this, we're going to go if current bullet dot draw. Alright, and if it's true, then it's just going to draw. Pretty simple. Now, if so, what we want to do now is go ahead and take in we're going to want to just change its y-axis, remember? To do this, we're just going to go bullets at the index 1, okay, dot y position, and what we're going to want to do is go ahead and set that equal to its y position minus the current ball's velocity, or the current bullet's velocity. Okay, now that that's done, what we want to actually do is go ahead and draw the circle. So we're going to go rl.draw circle, because remember, it's a circle, right? And we're going to take our current bullet, position x, okay, and we're actually going to want to minus 16 off of that. This is because, what's it called? We want the x position to be aligned with the center of the ship. The next thing we do is we just take our current bullet, dot position y, alright, and then we're just going to take our current position, or our current bullet dot radius, and then we're going to write current bullet dot color. Alright, okay, now the next thing we want to do is go ahead and check to see if, what I want to do now is just check to see if it's, leaving the screen, and if it is, I want to put current bullet.draw as false. To do this, just set up a pretty simple if statement. I will just check to see the current bullets dot position y, and check to see if 0 is greater than, or if current bullet dot position y, okay, is greater than the screen height. Now, if either of these statements are true, all I'm going to do is just go bullets, and then I'm going to go index 1, and I'm going to go ahead and dot draw, and set that equal to false. Now that all of that's done, so now that all of that's done, our bullet mechanism should be complete. So yeah, as you can see over here, we can move around the player. Okay, and once I click space, it fires. But I might be realizing something, and that is if I just keep on holding the space bar, it just goes like crazy. Now this is a pretty broken ability by itself, and it will also lead me to an epileptic seizure. In order for me to prevent this, what I need to do is set up some more restrictions. So the way I want it to be is that not like the original Space Invaders game, where until the bullet hits a player, or if it just leaves the screen, only then will it be able to shoot again. To do this, go before the infinite for loop and go ahead and create a boolean. This boolean will just be called should shoot. Var should shoot. And I'm going to go ahead and set that equal to true for now. Okay? And what I'm going to do now is I'm just going to go should shoot. Alright? And the next thing I'm going to do is go to my space controller, like what checks to see for the space, and write a simple AND statement for should shoot. So now if it's false, it's not going to run. Alright? The next thing I'm going to want to do is figure out a way to get should shoot to be, true. Now, in order to do this, what I want to do is go ahead and check to see if the bullet has left the screen. Only then should the person be allowed to shoot again. So I'll just go should shoot is equal to true, where the bullet has left the screen on either side. Okay. And let's go. What? The hell? Whoops. Okay. There appears to be a small problem. Okay, let's just go over what we did so far. First, we created a variable called should shoot. Okay, and we left should shoot as true. Oh, but we never put it as should shoot to be equal to false. We put should shoot equal to false each time it actually shoots. Now this should work. So yeah, as you can see, now it only shoots like one small bullet. And again, you guys might be also noticing that it's still a pretty fast. Don't worry about that, because now we're inserting our enemies. Once we insert our enemies, we will have a time.sleep which will slow everything down and make our game a lot smoother to play on. Creating and working with the enemies is arguably the hardest part of this video. So here's how it's going to go. So the first thing we want to do is just go ahead and actually create a struct for all of our enemies. The reason why we're doing this is because we're going to have an infinite amount of, or not an infinite amount of enemies, but we're going to have an undefined size. Alright, so to do this, go ahead and create a type and call it enemy struct, okay? So it's going to have the X and Y positions same as to that of the bullet. Like as in it's going to have the same attributes, not the same X and Y positions, although that is possible. The next thing I want to do is just create a boolean called image down. Okay, now the reason why I'm doing this is because if you guys can just see over here for these assets, right, there's two assets that the enemy will change out of. Now I constantly want them to change, right? So by having a boolean that checks true or false, we can just switch between the two. Alright, now that that's done, the next thing we need is to go ahead and actually make a boolean just to draw. This is because we don't want dead enemies to be drawn onto the screen. Now that that's done, let's go ahead and actually create our array of enemies. To do this, it's pretty straightforward. We're going to want to go and head on over, right over here, okay, right below the init window, okay, and what we're going to do is we're going to create one called enemies, and we're going to use a declarative operator and create a slice of enemy. Now that that's done, the next thing we want to do is go ahead and load in our images. So there's two enemies, as you remember, enemy 1, alright, which is just simply equal to, which we're just going to load, right? So rl.load image, okay, and we're just going to specify its path, assets / enemy1.png, okay? Now that that's done, we also want to go ahead and go with enemy2. Okay, and that's just going to be just enemy2.png. Now that that's done, we actually want to go ahead and convert these over into textures. So enemy1 will just be considered enemy up because it's, upwards, and then enemy2 will just be considered enemy down. So enemy up is just going to be equal to rl.loadTexture from image, and it's just going to be enemy1. Then we're going to go enemy down, okay, and we're just going to go ahead and go rl.loadTexture from image and just go enemy2. Now that that's all done, the next thing we want to do is go ahead and actually create some enemies. So as you saw earlier, there's 7 enemies. So now one way to do this is just to write every single one and append them. Now that's more of a Neanderthal way to do things. The way I'm going to do is just with a simple for loop. The first thing we're going to want to do is just create the number of enemies. So just go ahead and just make an integer and just call it enemy int or something. Alright, I'm going to set that equal to 7 because we have 7 enemies. The next thing we want is our current X position, right? So the way it works is that there's a bit of a gap between each enemy, otherwise they would all just be blobbed together. So for now, we're just going to have our current X be equal to 10. And it's going to later on change as the for loop goes on. Okay, so to do this, what just happened? Okay, sorry. So to do this, go ahead and make your for loop. So for enemy int, and set that in equal to 0. In the case that it is unequal, what I want to do is just first of all decrement the enemy integer. The next thing I want to do is go ahead and create a current enemy. To do so, I'm just going to current enemy and declarative operator as enemy. Declarator operator as enemy, and what how do you spell enemy again? Where is it? Enemy. Enemy, yeah. Yeah, so that's the right spelling. Okay. And what we're going to do is we're going to take in our current X value. Okay. Okay. I'm pretty sure it isn't in 32, is it not? Okay, it doesn't matter. The next thing we need is our Y position, which is going to be 100. Now 100 is going to be a constant because they're all in the same row. The next thing we need to write is whether or not we should, first of all, put the image down and to draw them. So originally I want the image to be down and then it's going to go up. So we're going to just write true for each of these. Then we're just going to want to go ahead and append everything into our enemy struct or slice here. So enemies is equal to append our enemies, comma, current enemy. Okay, now that all that's, so that's just the gist of it. Now we've gotten all of our enemies ready. The next thing we're going to want to go ahead and do now is actually go ahead and draw them. Before doing that, we also do need to draw in our speed. So we're just going to go var enemy underscore speed, and it's just going to be an int32 and just set that equal to 1. The reason why we're doing this, I'm going to explain, it's just to have some speed, and we're going to later on change that as it like each time they bump into the wall they go down a bit, right? Okay, so to draw them, we're actually going to draw them inside, or we're going to draw them outside of the bullets for loop, and then we're going to draw the bullets within the enemies. All right, but we're going to get to that in like a little bit. Okay, so first thing we're going to want to do is go ahead and just make our for loop. So for index comma current enemy. All right, and we're just going to range through all of the enemies. Okay, the next thing we do is go ahead and check to see if we should draw the enemies. So to do this, we're just going to go enemies dot enemies index dot draw. Where is it? Dot draw. Now, if this is true, then what we now need to do is go ahead and actually draw them. So in order to draw them, Or actually, wait, how do we draw them again? Oh yeah, so we're just gonna go like this. So first we're gonna do is we're just gonna check to see if the current enemy dot image down. Now, oh whoopsies, dot image down. Now, if the image is down, all we now need to do is just go ahead and draw over the texture. rl.draw texture, rl.draw texture, and it's going to be the up enemy. Wait, why is it up? No, it should be enemy down, sorry. Enemy down, okay. Then it's going to have our current enemies.x position. Wait, whoopsies. Current underscore enemy dot position x. Okay. I'm just going to remove this over. Yeah, it's going to have its x position. Then what it's going to have is our current enemy dot y position. Current enemy dot position y. Okay. And we're going to have rl dot white. Okay. Now that all of that's done, yeah, so now in the case that this is not true, right? What we're going to want to do is just go ahead and draw the up image. So just go ahead and paste this like so. Okay, and it's just going to go and just do enemy up instead of enemy down. Now that that's done, yeah, so now that that's done, we can actually just go ahead and actually run this, I'm pretty sure. Conversion line. Oh, sorry, it's supposed to be a struct. Okay, let's just try and run this. Enemy speed declared, but not you. Oh yeah. Yeah, that's gonna be a bit of a problem. So yeah, I have enemy speed here, but I'm gonna comment that out for now. I just want to show you guys what we have so far. So yeah, as you can see, currently we have one enemy over. All right, now let's go ahead and just draw all of these over into our screen. So let's just see what went wrong. Yes, so we did it. So when we took our current x position, right, we forgot to go ahead and add over 50. So the reason why we're adding, or actually let's just add 75 pixels. The reason why we're adding 75 pixels is so that we can actually get a bit of a distance between the enemies. All right, now as you can see, all the enemies are appearing. Okay, now as you can see right now, the enemies are neither moving nor changing inside of, or nor changing in, what's it called, animation. So let's first go ahead and change the animation. So to do this, all I'm going to go ahead and do is take in enemies, okay, the index dot, what are we going to do now, dot draw, and set that equal to false. And similarly, inside of our else statement, we're just going to go current enemy dot image dot, or actually no, not draw, dot image down, and set that equal to true. Okay, so as a result, it's going to lead to this infinite loop where it just keeps changing. So if we go ahead and run that, here we go. So as you can see, they're changing, right? Now you can see that they're moving a bit fast. Now that's another problem. Now the way we fix this is pretty simple. What we want to use is the time and the random, or we're just going to want to use time for now. All right, and what time is going to help us do is just slow down our code. Okay, so to do this, head on over right over here, and the first thing you're going to want to do is just import time. And then what you're going to want to do is just go back to this looping mechanism and go right at the end of the if statement right here, and just go time.sleep, and you're going to want to sleep for about half a second. All right, because you don't want to sleep too long, otherwise it will lag. All right, so we're going to go 5, 1, 2, 3, 4, 5, 6. That's roughly half a second, I believe. Okay, and another thing we also want to go ahead and do is just go ahead and take our bullets for loop and just put it in here. Okay, now let's see how this goes. I'm going to go ahead and run this. Okay, now right now, as you can see, the player moves a lot better. And when I shoot, you can actually see the shoot a lot easier and a lot slower. Okay, now that all of this is done, we need to actually get our enemies moving. To get the enemies moving, first thing we're going to want to do is just uncomment that line we did with the enemy speed. Once we do that, you're going to want to head on over right after the bullet for loop ends and while we're still inside of the enemy's for loop. Inside of here, we're going to want to add some basic Boolean logic. The Boolean logic works like this. The first thing we do is go ahead and check to see the current enemy's X and Y positions. Like so. Okay, so to do this, we're just going to go if current enemy dot position X is greater than or equal to 0. Now, if it is, what I want to do is take our enemy speed and set that equal to 1. Now, let's suppose if the enemy speed is greater than the screen width, I want to subtract by 1. I'm going to go else if current enemy dot position X and check to see if it's greater than or equal to the screen width. Now, if it is, we go enemy speed and set that equal to -1. The next thing we're going to want to go ahead and do is just write a simple else statement. We're not going to do anything in there. The next thing we do is just go enemies, and we're going to write the index of the X position, and we're going to increment the enemy speed. All right. Enemy. Yeah, there we go. Now let's go ahead and run this and see how it goes. Okay, so as you can see, they're moving. Now watch what happens when it hits all the way to the end. Okay? It's hit to the end, now it's moving all the way back. And it's just going to move up, it's just going to move around like that until, you know, until the game basically ends. Now, we need our enemies to actually fall down one layer. Otherwise, what happens is that there's no like daunting scare that the enemies might come after you. Okay? To do this, what we're going to want to go ahead and do is first of all check to see if the enemy's X positions have interacted with any of the sides of the screen. To do this, we're going to want to go up above the bullet. We're going to want to go up above the X. We're going to want to write it right above the bullets for loop. Okay, and what we're going to want to do is just take our current. So we're going to want to do current enemy dot position X. Okay, and see if that's equal to 0, or if our current enemy dot position X is equal to the screen width. Now, if either of those things are true, what we now need to go ahead and do is take in a for loop with every single one of our enemies and increment 5 to it. All right, so to do this, I'm just going to go I, comma, blank. In Go, you write a blank if you don't want to specify any variable value. Okay, we're just going to range through the enemies real quick. And then what we're going to do is just go ahead and go enemies at index I, okay, dot position Y, and we're going to want to add 5. Okay, now let's see how this goes. I'm going to go ahead and run this. Okay, and as you can see, the enemies are going all the way to the side. Now watch what happens when they hit bottom. As you can see, they all fall all the way back down. And all the way back down. Boom. Now we got our entire walking mechanisms for our enemies ready. Now that that's done, what we want to do now is go ahead and set up our shooting mechanism. So the way it works is that I want there to be roughly a 5 or 10% chance for an enemy to shoot. And if it shoots, it's just going to create a circle similar to how the bullet mechanism works for the player. Okay, now to do this, it's pretty straightforward. The first thing we're going to want to go ahead and do is add in our random library. So to do this, head on over here and just go math/rand. Okay, first we're going to set up our random library. So we're going to go in if image.draw, and right below that we're going to set up our random generator. Okay, to do this, the first thing we're going to want to do is go ahead and create a brand new variable called var enemy underscore shoot and set that equal to an int 32. All right, and what we're going to do is we're just going to go ahead and randomly generate a number from 0 to 199 dot int n, and it's just going to be 200, right? Because it minuses off 1. Now the next thing we're going to want to do is just make a simple if statement. Our if statement is then going to go ahead and check to see, what's it going to check to see? It's going to go ahead and check to see if it's equal to 10. To do this, we're just going to go like this. Whoops. If enemy underscore shoot is equal to 10. Now, in the case that it is equal to 10, what we now need to do is go ahead and create a brand new bullet. To create the new bullet is pretty straightforward. So to creating it is pretty straightforward. First, what we're going to do is we're going to find out the space bullet right over here. And we're just going to go ahead and actually just modify this. We're going to paste that. Okay, but it's going to have quite a bit of modifications, as I just said. The first modification that we have is that it's going to have a red color. Okay, so rl.red. The next thing it's going to have is a velocity of actually -5, capital R. Okay, the next thing we're going to want to do is specify our x and y coordinates. So we're actually going to keep our y coordinates the same. Okay, we're actually just going to mess around with our x coordinates. And the reason behind this is because, the reason behind this is pretty straightforward. The reason why we're messing around with our x coordinates is because we want it to be at the center of the player, which is just going to be, it's 24 pixels. Okay? Now, and then we're just going to append it over. Now let's go ahead and run and see what's happening here. Okay. Okay. We have our x coordinates. What we should have done is just go current enemy dot position x, and we just go current enemy dot position y. Enemy dot position y. Okay. Now that that's done, let's go ahead and run this. Yeah. So as you can see over here, the player is actually shooting. Yeah. So the player is being shot towards. Now we've actually completed everything regarding the enemy. Now the next thing we're going to want to go ahead and continue on is the colliders and end screen of the game. So let's go ahead and start that. Alright, so in order to check to see if the enemies are, touching the bullets, and in order to make them disappear, we're going to have to use colliders. So we're going to have two main if statements that are going to deal with this. So head on over to where your bullets are, and we're going to go ahead and work on it over here. So the first thing we're going to want to do is check to see if the enemy itself is touching the bullet. So first thing we're going to want to do is just go ahead and create a check for collisions. So we're going to go if rl.check collisions, and we're going to be actually using rectangles. All right, collisions rex. Okay, and we're going to go ahead and create two rectangles. These two rectangles are first of all going to be one for the current bullet and two for the current enemy. All right, so we're going to want to go rl.new rectangle. All right, and this new rectangle is first of all going to have, so in the new rectangle, right, there's the setting requires you to have a float 32. So what we're going to want to have to do now is actually go ahead and convert everything to a float 32. We're going to go float 32, current bullet dot position x. Then what we're going to want to do is take in float 32, current bullet dot position y. The next thing we're going to want to do is just go float 32. Okay, and it's going to have in the, what's it going to have? It's going to go ahead and have in our the width and our height. So the width and the height is simply just a 60 by 32. So we're going to go 60, comma float 32, and it's just going to be, well, you guessed it, 32. Okay, now that that's done, the next thing we're going to want to also check is to see if the next thing we're going to want to go ahead and check. The next thing we're going to want to go ahead and check to see is if the if it touches with the current enemy. So to do this, we're just going to first of all make a comma right over here. All right, and then what we're going to want to do is just go rl.new rectangle. Okay, and inside of that new rectangle, what we're going to want to do is just go float 32 and put in our current enemy dot position x. Okay, the next one we're going to want is our position y. with our current enemy. Float 32 current enemy, current, crap, yeah, current enemy dot position y. The next thing we're going to want to go ahead and do is grab in our, we're going to also just go float 32, and it's just going to also be, what's this going to be? This is going to go ahead and be, oh, wait a minute. Oh, we made a small mistake over here. This should be float 3260 and float 3232. And I'm going to explain to you guys that in a moment. So over here, what we're actually supposed to do is actually take in our current bullet dot radius. Current bullet dot radius. Now the mistake that I accidentally did was that I accidentally gave the bullets itself their the specifications of the current enemy's specifications. So that led to a bit of a confusion. But now that that's done, current enemy is not declared. Yeah, okay. Collisions direct. Okay, yeah. Now that that's done, the next thing we're going to want to go ahead and do is actually check to see if the bullet's color is white. This is because we don't want the red bullets to, interact with them. So to do this, we're just going to go current bullet dot color, current bullet dot color. Okay, and we're just going to set the color equal to RL dot white. Oh, and we're also going to want to go ahead and check to see if the current enemy is being drawn. Current enemy dot draw. All right. Okay. I think that should be it. Wait, new rectangle, comma, and new rectangle. Okay. Yeah, so that's just the gist of everything there is. Okay, and if this is all true, then what we're going to want to do is just take in our current enemy, and I'm going to put dot draw and set that equal to false. So let's just go ahead and run this code for now. RL dot check collision rec. Collision rec. Okay, now let's go ahead and run that. Current bullet. Wait, there appears to be another error. Dot draw enemies. Oh yeah, what we have to do is actually take in our current enemy, and wait, I accidentally wrote the false as incorrect. We're gonna go enemies. We're gonna go index.draw. Okay, now let's go ahead and just run this and just see how it looks. So we're gonna go run main.go. Okay, and if we move around, and as you can see, once it interacts, it all disappears. Okay, now we're going to want to go ahead and repeat this exact same process for the player himself. Okay, so in order to do this, what we're going to want to do is add in another if statement right below over here. Okay, and to do this, and over here, we're actually going to replace some things. First of all, we're going to check to see if the color is equal to red. The next thing we're going to want to check to see is, the next thing we're going to want to do is just remove the current enemy dot draw. Okay, this is because sometimes the enemy might shoot something and then die, but that bullet still counts because it still exists, Now, inside of our collisions for the first rectangle, we first use current bullet, or no, for the second one we use current enemy, right? Instead, what we want to use instead of current enemy is actually the x coordinates. Okay, then we want our y coordinates. Okay, yeah, we're going to want our y coordinates. Y chords. Okay, now the rest of it's just going to be the same throughout because the images are nearly identical. Now let's see what happens. Okay, let's go like this. And wait, actually, we're going to actually want to go ahead and do something here, right? So right now, I just want to detect to see if it actually runs. So in order to do that, we're actually going to go ahead and import this FMT library. This is so that we can print stuff out. Here we go. This is just a format library, so it's the format library. Okay, and we're just going to go all the way down here back to where it was. We're just going to go fmt.println hit. Okay. All right. Now let's go ahead and run this. Okay, you guys can't see this. All right. Now, okay, I'm just gonna write D over here, right? Now, as you can see, we're actually getting some hits over here, right? Like, I'm just gonna show you guys. One sec. Let's just wait for it to, hit. Yeah, so as you can see, it actually hit. All right. Now let's actually just reduce the frequency of how quickly it hits. And let's just turn that over into 300. This way, it's gonna be a bit more smoother and a lot less harder. Okay. Yeah. All right. Now that this is all done, we're going to want to go ahead and add two things. First of all, we're going to figure out a way to actually end the game. And the second thing we're actually going to want to do is go ahead and actually add some, what's it called? We're going to want to go ahead and add some, what's it called? Yeah, we're going to also want to go ahead and add some end screens and scoring and all that kind of stuff. So let's get to it. Hey everyone, future me here. I realized there was a small mistake in the game. So right now the issue with the game is actually pretty fixable. Let me just show you guys what the issue with the game is. So as you can see, when I'm hitting these players, right, they begin to go a lot faster. And I also begin to go a lot faster. Alright, and the reason behind this is because I've made an issue with the sleeping mechanism. Alright, now fixing this is very straightforward. Observe. The first thing we're going to want to do is just go if we're going to figure out the ending curly braces for where it draws. The next thing we're going to want to do is first of all take out our range of bullets and the time.sleep. You're going to want to take that and cut it out. Okay? You're just going to paste it right outside. Now, if we were to run this, okay? Now watch what happens when I try and kill one. As you can see, it's not slowing down, and as a result, the game's a lot more smoother and easier to play. So clearly, yeah, so fixing that wasn't that hard. Alright, sorry for any inconveniences. Anyways, let's just get on with the video. Alright, so before actually creating an end screen, what I want to first of all do is go ahead and create some basic UI that shows the score. And then what we're going to do is then set up an end screen for it if the player dies or, if the player wins altogether. Alright, here's how it's going to work. The first thing we're going to want to do is head on over before the infinite for loop. Okay? And what we're going to want to do over here is go ahead and create a variable called score. Okay? And you guys might already know what I'm trying to do here. So just make it a simple integer. Var score, and make it an integer and set that equal to 0. The next thing we're going to want to do is go ahead and actually display this onto in our game. So to do this, let's go right over here, right before anything big happens. I'm going to write it over here. We're going to go rl draw text. Okay, and we're just going to go ahead and draw in score. Okay, and actually we also need to import the string conversion library. String conv. I think that's it. Yeah, that's that. Okay, where is it? Yeah, score. And what we will want to do is just go ahead and add string con dot and itoai, and we're just taking the value of score. And we're going to put this at the coordinates 0, 0, and we're going to have a font of about 20, and we're going to use the font color of light gray. rl dot light gray. Okay, oh, that's a comma. Okay, now that that's done, we also, what's for the problem? Cannot use type variable rl in 32. Oh, there we go. Now the next thing we also want to do is go ahead and actually, increase the score value. So the only time we actually increase the score value is if the bullet were to actually touch the enemy. Now to do this, head on over to the collision where it shows the enemy and the bullet colliding. If they do, go over here, score, and add 50. Now that's actually the score that the game works on. So let's go ahead and just see our progress so far. Yeah, so as you can see, we have our score right over here. Okay, now if I were to hit, our scores increase by 50, 10, you know. Okay, now the next thing we're going to want to go ahead and add is the end screen. Okay, so the game will only end in two different scenarios. If the enemy has been killed, or if all enemies have been killed, or if the player has been killed. Let's first work on the enemy. So to do this, we're going to go over here and just create another variable and just make it an integer. Var total enemies. Okay, we're going to set that equal to 7. Why are we setting it equal to 7? Because that's the total amount of enemies there are. Pretty obvious if you ask me. Okay, and we're going to make this an integer. And each time an enemy dies, okay, what we're going to do is we're just going to go total enemies minus minus. All right? The next thing we're going to want to do is go ahead and create a boolean. Okay, this boolean is going to check to see if the game is over. So initially the variable is just going to be false for obvious reasons. But if the total number of enemies is now 0, then what we're going to want to do is just take game over and put it as false. So to do this, go over here. We're going to go right over here. If game over is true, or actually wait, no. If total enemies, what the hell? Sorry. If total enemies is equal to 0, we're going to go game over and set that equal to true. All right. And the reason why we're not just immediately setting up our end screen is because, and I'll explain that to you guys in a moment. It's mainly just because each time the enemy gets, the player gets hit, we're going to set that equal to true. In fact, let's just do that right now. Where's the print line? Instead of putting hit, we're just going to put over here game over as true. All right. Now, the next thing we do is just check to see if game over, so like it'll only run if it's true, by the way. The first thing we're going to want to do is go ahead and stop everything. And what I mean by stop everything is this. First of all, we're going to take in our enemies, okay, and just convert that into nil. The next thing we're going to want to do is take in our bullets, okay, and set that equal to nil as well. The next thing we do is unload our texture. We're going to go rl.unload unload texture, and we're going to unload the texture of our ship. The next thing we're going to want to do is take our x coordinates, okay, and set that equal to 1000. This is because Raylib sometimes can be pretty stupid, and what it does is it won't let even though I unload a texture, an image may still appear. So all I'm doing is I'm just transporting it all the way across the screen so no one can see it. Not the most efficient idea, but it works. And frankly, I could care less. Now, the next thing we're going to want to do is just go ahead and display our final score. To do this, we're actually just going to yoink from here. Okay, and we're going to write your final score. Okay, and we're actually going to change the location as to where this is located. We're going to put it to 30, 80, and we're going to make it a bit bigger, font size 30. Now, the next thing we actually want to do is go ahead and make it an option for the player to restart. To do this, what we're going to do, actually, let's put that in as 40 and put that in as 80. Yeah. To do this, what we're going to do is just write press enter to restart. Press enter to restart. Okay, now that that's done, we actually need to check to see if if the key is down for enter. We're going to go if rl dot is key down, and we're just going to go rl dot key enter. Now, if that is true, god damn it. Now, if that is true, we're going to want to first of all just go rl dot close the window. Okay. Dot close window. Okay, then we're going to want to launch the main function. All right, and otherwise, nothing really happens. All right, now let's try and run this. Sorry, I just died. I'm just gonna display it after. Okay. Okay, now I'm gonna shoot. So let's just try and kill everyone first. Okay. Score is 250, 300. Yeah, so as you can see, it says my score is 350. Press enter to restart. It accidentally transported me to the other screen. But let's see if it actually even collides with the player. Let's see. Yeah, so as you can see, I just died. Okay, and I just transported it to the other screen. So yeah, as you can see, we just created an entire Space Invaders game inside of Raylib. Thank you guys for watching. If you guys have any questions, leave them in the comments below. Anything you need me to help you guys with. Thank you guys for watching. Have a nice day.